Hello guys, hope you're doing well. And as always, if you are new to my channel, I would humbly request you to subscribe to my channel. Thanks. Okay, so let's do another problem related to product of inertia calculation or product moment of area calculation for an L section beam. Okay, so let's read the problem first. Okay, you need to determine the product of inertia for the beam's cross-sectional area with respect to x and y axes that have their origin located at the centroid C. Okay, so just to let you know that this is our L section beam. Okay, and if you look at it, this beam, these are x and y axes, but they have basically given us this centroid C. Okay, for this which is located at the intersection of x and y, and the dimensions related to this centroids are basically from this end it is 7.5 millimeters, and from this end basically it is 17.5 millimeters. Okay, so these are, so you need to calculate all your related calculations needs to be done for, especially for dx and dy with respect to this centroid C. Okay, and another important point that we will be doing centroid to centroid details calculation. Okay, so for whether it is dx or dy, it will be the centroid of the respective segment under consideration with respect to the centroid of this L section beam C. Okay, so this point is very important to remember. Okay, so let's start solving this problem. Okay, I have made it, this is our major diagram, and I have basically shown you the centroid to centroid details for the section. Okay, which will make things easier for you guys. The dimensional details of the L section beam is 30 millimeters and 50 millimeters. Okay, so we have two segments, segment A and segment B. If you look at the segment A first, which is this one, this is our segment A, whose area is basically 30 into 5. If you look at it, this area is 30 into 5. Now we are very much interested in calculating dx. So if you need to calculate dx, what we will do is that we have the centroid of this section of 30 into 10 is located at this point. Okay, so if you look at it, and the actual centroid of our figure is basically this is the parent centroid. So we need to calculate the distance between this C and this C. So what we will be doing here is that from this point to this point it is going to be 15. And what about the distance of this centroid? It is given as 7.5. So if we subtract from 15 to this distance 7.5, we will get the centroid to centroid distance, which is this one, from this point to this point. Okay, linearly, this point to this point, and that comes out to be 15 minus 7.5 equals to 7.5 millimeters. Now we are also interested to calculate the distance, which is basically from this point to this point. Okay, so if you look at it, just to let you know, this is my positive x, positive y. Any dimension measured from this point lower side, okay, will be considered as a negative y basically coordinate, and any dimension from this point to the other side of this x-axis, which is negative, will be considered as a negative coordinate. Okay, for this L section B. So when we calculate this, you know that this height of the centroid is 17.5 millimeters, and if I basically minus because it is dy minus this total depth of this base is 5 millimeters, so the center of this 5 millimeter is 2.5, so it will be 17.5 minus 2.5 millimeter. But you can see this 17.5 minus 2.5 is a dimension which is lying on the negative y, so we put a minus sign. Do the multiplication and you get this value. Now let's go for the other one, and this is the other section of this L beam, and again we have the dimensions for this beam is not 50 because our first section is this one, the base section is this, so its dimensions are reduced to 45 into 5, which starts from this point to this point. 45 into 5. Now what will be the dx of this section? Okay, so if you look at it, it is going to be basically from this point to this point, from this point to this point. So you already know that this is basically, because this is the dx, so from this point to this point it will be 7.5. Okay, and you know, if you subtract this 2.5 from it, 7.5 is this, and you subtract this 2.5, you will get centroid to centroid distance. Okay, so it is basically comes out to be 7.5 minus 2.5 is going to be 5. But see, this 5 is this distance, which is not on the positive x but on the negative x. So once this is being done, we can basically uh, once this is being done, we can basically calculate it as minus 5. Okay, now let's go for dy. If you go for dy, you know it very well that it will be basically the height from this point to this point. We actually want it. How we will go for that is basically, we know that since this section height is 45, so the half will be 22.5 from starting from this point to this point, 22.5, and you minus basically this height. If you minus this height, because we start our 22.5 from this point to this centroid, and if we know this height, we will basically get the centroid from this point to this point. Okay, so it will be 22.5 minus 12.5, and it will be 10. So you multiply the three values and you will get this. Now because both of them are minus, we can add them, and we will come up to the product of inertia for this L section beam for this configuration is going to be minus 28.125 into 10 to the power 3 millimeter 4. Okay, so I hope this problem will assist you in your future endeavors. You have a wonderful day, and thanks.